So, again, this is ST589, Fundamentals of Information Technology. This is lecture 13. I'm Rob Hepler, of course. Today we're going to talk about chapter 11, which is Information Systems Development. We're going to talk about half of that process. The first half we're going to talk about tonight is systems analysis and design. That's the job I have done for a lot of years and really enjoy. It's a very challenging job doing all that because you're the center of everything and you have to be the liaison between the technical, non-technical people. You have to know a little business, you have to know a little technology, you have to know personalities, you have to know people. I find it a lot of fun. And every project you do, you learn a little more about a business. I did it as in-house, which meant I worked for an information systems department. I also did it as a consultant for a lot of years and helped people, on a contract basis. And both of those are challenging. The consultant one is very challenging on the personal level because people tend to think, who the heck is this person coming from outside and telling me how to do my job? So you have to overcome that as well as learn the business. But they're both a lot of fun. So information systems development is about developing systems. And I know in the current environment today, a lot of people think they know enough about technology. They write a program. They think, well, how hard can it be? It's a program. They don't consider all the other things. A system isn't just a program. It isn't just a bunch of programs. It's a lot of things. It's people, it's machines, it's programs, it's paper, it's process. It's a lot of things. If it was just a program, this would be easy, and a lot of people think it is easy. So the history teacher at a school ends up writing the inventory system for the school with no plan, just jumps right in, and what you get is often, I'm not going to say always, there are some people who are very good at it, but what you often get is a system that kind of works but never quite works right. And it's a lot of frustrating things, and you're constantly telling people to do things they shouldn't have to do. For instance, the people that use the system should just use the system and not have to worry about anything else rather than hear about servers. That word should never come up to a business user. They don't care. They want to just use the system. And when I hear people that don't have technical backgrounds using technical words because the programmer told them they needed to know about, well, the server doesn't do that, that means they didn't design a system. They wrote a few programs. And I hope you get the distinction there. And what we're going to talk about is how to do that the right way. So we're going to talk about project management, and of course that is the key to systems analysis and the systems analyst. Project management is how you handle all these things you have to do. So it's a key part. Most systems analysts have some background in project management, a certification or classes. When I teach systems analysis, and I'm teaching a class from Maryland often, one of the things you talk about is project management, and there's also a class in project management, the IT degrees in most universities. Feasibility. In other words, one of the most famous questions you should never ask a technical person, especially a programmer, is, can you do this? The answer is always yes. Given enough time, enough budget, enough resources, you can do anything on a computer pretty much. So the question shouldn't be, can you do it? The question is it feasible to do it? Can you do it within this time, for this money, with these people? That kind of thing. Feasible means, is it worth doing within our constraints or within our business? If it takes you 10 years to do something, it doesn't help the business a whole lot because by then it's going to be obsolete. You get the idea. So we'll talk about feasibility. Documentation, something that's often forgotten. It's crucial. The person that does the system, the analyst, the programmer, isn't going to be there forever. So you need to leave something behind for the other people to maintain the system, or if they want to modify the system. Documentation does that. Data and information gathering techniques. So you're told you need to develop a new production system to manage your production at a factory. So you need software, but how do you gather the information? I've never worked on an assembly line factory. How do you do that? Well, there are techniques to do that. The first one, of course, is to tell the people you're talking to, I don't know anything about this, tell me your job. That's the first step. Information system security, very crucial these days, more so every day. So as I mentioned earlier, an information system in the system development life cycle, and I'm going to just real quick, oops, go over here to the whiteboard. System development life cycle. And that's a standard term. And the idea is, of course, that you break the process into phases. You have specific tasks you do within each phase. And between each phase, you have what we call milestones. And what you do with milestones is you have some kind of document, some kind of prototype, something to show people and say, this is what I understood what you told me. This is what we're going to do in the next step or the next phase of the project. And everybody signs it. It's crucial, especially for you, the analyst. It's a step where everybody has to sit up and take notice and take responsibility. The systems analyst does not take responsibility for the business end of things. It's not the job of the systems analyst. You have a business partner that does that, and that's what I call them, business partner. Some people would call that the user. I like the term business partner because they're the business people and you're not. They're the people that are going to have to use the system and you're not. I'm exaggerating a little bit, but you get the idea. Systems analysts do not make business decisions. Business partners make business decisions. And that's a crucial thing. I went through some hard times where I learned that as an analyst. I often was left holding the bag, making business decisions, often because the people I was working with didn't know their job very well, and that you'll find that's often the case if you're a consultant, because that's why you're hired, to help them. The whole process of the project is to help them learn their job in a sense. And that's a skill to get around that problem. But one of the things you have to do is be sure you're not responsible for business decisions. So the systems development life cycle is an attempt to put structure to that. The early days of information technology is the idea that I can go out and learn Flash and write a program and I'm ready to go and let's put it in production and let's go. Well, that really, when you're talking about, especially in the early days, how expensive it was to buy computers and to do things, not a good way to go. A lot of processes failed, and so now we've developed this process. And I think we're getting away from it a little bit these days. The technology is getting so easier to use, but big corporations still use some version of this. There's no one single version. I remember consulting in a company that had 37 volumes of how you do a systems development lifecycle. You could pull out a template that said, here's the things you need to ask people. And if you didn't follow their template, they kind of wondered if you knew what you were doing. But the idea essentially is break it into phases so you can just make a decision about whether to go to the next phase. So SDLC, System Development Lifecycle. All right. An information system, notice, hardware. Okay, that's, as we know, that's this stuff. Stuff you can touch. The software, the stuff you can't touch. Most people think that's what it is to do technical things. Write a program, we're done. Well, it's never that easy. You have to be sure the software runs efficiently on the hardware. You have to be sure the combination of the two matches the expectations of the company. How fast do they want to have the computer respond? How often will people be accessing it? How much data is there going to be stored? All of those things. You can write a program, but if you don't have any place to put the data or you run out of space, you've just, your system isn't going to work. Data is part of the system. Of course it is, which means you have to look at where does the data come from? Where does the data go in the end? Do I store it? How long do I store it? One of the biggest flaws of many systems that are developed is people don't think about how long to keep the data. And when you don't want it any longer, do you just get rid of it? Do you archive it? Do you put it somewhere else? All of those things, backup, recovery, data archiving, and moving the data off the system. When I did systems for the UNM years ago, we had to think about all those things because there were laws, you know, about how long you had to keep grades and transcripts and those kinds of things. So you need to think about all that. People, this is the one that's often forgotten. Without people, you don't have a system. So this idea of writing a program and just, well, people can use that. Well, that doesn't really fly because if you don't involve the people that are going to use the system, they're not going to want to use it. And I can tell you from experience, if you don't get the people involved, they're going to be pretty sure the system doesn't work for some reason or another. So you have to include the people, get their input, and also you'll get a better system, obviously. Procedures. Now that's not even technology. It's got to be a way, a process to go through, and what businesses often look at, what do businesses need to do? Reduce cost or increase sales? Those are the two things businesses do to make more money. There's really nothing else you can do. There's ways to increase sales by producing a new product, or you can make it quicker to produce a product. There's a lot of things you can do, but those are the things you need to do. Procedures are what can make and break that process or an information system. You may design the best system in the world, but if the procedures aren't going to work with the people you have or within the time you have a problem. So that's part of the system. And of course, they work together. The system, a system, I'm sorry, is right there. Businesses use a lot of systems. All right. Oops. Here is the SDLC, a little more detail. Let's go over this a little bit. We have, and notice that's the idea, it's called a life cycle, because in the end, you're going right back into the first phase again. Normally that's what happens. The first phase is planning, and the idea there is let's figure out what we want to do. And notice, part of that planning, you get input from all kinds of people, and you may have forms that people have to submit. I need this to happen. And somebody, usually a steering committee, decides what projects you're going to do, number one. We'll talk about how you make those decisions a little bit. Number two, then you have to prioritize those projects because you only have so much resources and so much time. And then you have to allocate the resources. Somebody has to make that decision. And of course, that has to be part of the process of deciding what to do. That's the feasibility, partially the feasibility. And then we form a team. And the key to this, the steering committee, if there is such a thing, deciding on projects for IT, is you have people from each department, each area of the business deciding what to do next. And I know if you work at a small organization or school, as in your case, you don't see a lot of this, of course, but I can guarantee you probably at the district or city level, this sort of thing does go on. And they do have committees, not probably as big as GM and so forth, but there is some kind of process that has to do this. Whether it's informal or formal, this does go on. And it's my feeling that if you understand that a little more, you're going to understand how decisions are made and why things happen the way they do in terms of getting your information systems changed or made better. So you form a team, just like the steering committee. That team needs to have people that are going to use the system, business partners, and technical people, and the systems analysts to make it all work together. Then you have a milestone. Each phase here has a go, no-go decision. So some sort of document is created here. Usually a feasibility document or something. And everybody looks at it and says, oh, these are the people you need, these are the resources you need, here's what we're going to get out of this, here's, you know, and so forth. Everybody signs off on it, and then we decide, you know what, that's nice, but this project, we don't want to go to the next phase because we can't afford to spend that many resources, or the return on this project isn't good enough. So we're not rejecting it necessarily, although sometimes that happens. It isn't feasible. The market's already moved beyond it. We don't need this anymore because it took too long. So we won't go to the second phase. However, if it does go beyond that milestone and everybody reads the documents and discusses and decides, let's go to the next phase because we need more detail. We need to know more about it, what's going to happen. So the analyst, the team really, with the analyst leading the way, gathers information or the preliminary investigation. So you need to look at what is there, the existing system. And you might say, well, there is no computer system today. Well, there's still a system of some kind. You're not inventing something for no reason. There's a reason you're automating it, but there's an existing system. And you need to know what is going on before you can look at how to make that better. So that's what you first do. Study the current system, whether it's automated or not, and document it so you understand it, so the team understands it. And I know some of the people on the team are going to be so deeply involved they think they understand it. But the idea is to get everyone to understand it that's working on the project. Again, at your location, there might just be one person doing all this. But it's still, the process is similar. It just doesn't involve as many people. So you study the current system. Then you determine the requirements. And you list them, the user requirements. The requirements are, how often do you need this report? What data do you need? How quickly do you need that data? What computations do you need? How many people are going to use it? How many computers do you need? What sort of training do you need? All those things are requirements. Why do you need requirements? That's your goal. You have to nail that down or you're just shooting at anything randomly. That's what requirements are. They're your bullseye. That's your target you're shooting for. So the requirements give you the goal, where you're heading. And of course, to get that goal, you need to do the prior analysis to look at the current system. Then you recommend a solution. For instance, I mean, a lot of this is obvious, but here's an example you might not have thought of. You said in the requirements you needed a response time of half a second out of 10 million records. Well, if you really want that, the only solution that works is an $85 billion computer. But here's the solution. But if you want to modify the requirements, I can give you a computer for $1 million. You know, those kinds of things. There's trade-offs. So often you give more than one solution. Give the pros and cons. You state the constraints. You said you had to have this requirement and this many records. Those kinds of things. It's a real skill. And guess what happens then? Another milestone. What you have now is the analysis document, the systems requirement, some people call it. And what you're talking about here is the what. What are we trying to do here? Or some call it the logical picture. At this point, you don't really want to talk about the how you're going to do it, what technology. What we're talking about here is this what you do now? Is this what you want it to do later? Is this what you want to add on? Because if it isn't what you're doing now, we need to go back. We missed something over here. Okay? That's the idea. So everyone reads the document or discusses it and says, well, you know, you forgot about Fred over in accounting. He needs to be part of this process because it's very crucial to everything that what he does be included here, and he's not even in here. Oh, isn't so much Fred, it's his functions, what he does, his job. So you go back. Somebody rejected this document. You go back, include that, and you create another milestone document. At some point, everybody agrees, or at least says, this is what we're going to do. This is what we do. This is what we want. This is the logical picture, we say. Let's move on to the next phase. And of course, that agreement to move on also includes resources, dollars, and time. So if you're committed at this point, that means you have enough dollars and time and people. People are really dollars. You might think about it that way. To move to the next phase, which is the how, the design. Now we're going to draw the physical picture, some people call it. Of what the system will look like. And I wouldn't say acquire the hardware necessarily. I'd say specify would be a better word in my experience. Because you don't want to buy hardware and then if you decide not to do the project, what do you do with the hardware? So normally you buy the hardware down here, but people think differently. So you specify the hardware. Here's what we recommend. We buy. You draw a picture of how the new system is going to look like, how you're going to do it. Now we're talking technical. Talking about these sorts of servers, these sorts of monitors, this sort of network infrastructure, this database. All those things are designed. And we get a picture. Another milestone, which is the design document. Picture of how we want the system to be. Technical pictures that specify computers, programs, and many times you get down to exactly the details of how the programs will run. You actually create all that logic of the program if you have that many people. So you have specifications, hardware, software, procedures, what's expected of people, and so forth. Then you move on. Implementation, which of course means you're going to make it happen. Develop the programs. Notice it says if necessary. Sometimes you use existing code or you buy code, something like that. We'll talk more about that later. Install and test. Crucial. You just don't, I know I see this all the time here at New Mexico Tech. Somebody writes a program, they slam it in, and guess what? It usually doesn't work. They tested it on their computer, but in real life production, there's things you can't think about. So testing is an art unto itself. Install and test the new system, and we'll talk about some of these things in detail. Here's one that's often overlooked. Train the people that are going to use it. And these people that don't understand technology, this is another one they often miss. They write their programs, throw it out there, and say, I know how to use this. This is easy. You got to be a dummy not to know how to run this program. Well, it's not about being a dummy. It's about having 8 million other things to do at work and not taking the time to even think about how this runs, number one. So somebody needs to set time aside and say, here's how this works. Here's how you do it. Or it really isn't as easy as the programmer thinks. The programmer knows how it works. So you need to train people. Otherwise, the system will fail. Then you have to convert. What that means is, of course, you install the new system and get rid of the old system. And there's strategies to make that happen as well. Then we move on here. There's another milestone here. In this case, test or acceptance. The business partner says, all right, this system does what you said it would do. Close enough. We'll allow you to move on. And of course, if they don't accept it, you have to go back here. And sometimes you have to go back here, sometimes back here. because you forgot something or you didn't understand something. So acceptance is about that. You don't always go back one step. You may have to go design something again, or it might be that the programmer misunderstood the specs, or the programmer didn't test it well enough, or the data was incorrect. There's a lot of things that could happen. That's one of the reasons we have these milestones. The sooner you find the error, the cheaper it is to fix, and the easier it is to fix. Once you've written 1 billion lines of code, it becomes more difficult to change things, fix errors. The milestone is test or acceptance. Then we move into the final phase if the user accepts the system, and often as you're testing, as you're accepting the system, you're also making a list of things that need to be fixed, believe it or not, changed, enhanced. You usually have like 3 lists. Critical stuff, we need to get this done now. Stuff that, okay, we can live with that for now. And stuff that, man, it'd be nice if we had. And that happens during testing. People go, you know what, we didn't think of this, so let's put it on the enhancements list. But it's going to work. Once it's in production, we're over here to the last phase, which is maintain it. That's making errors, corrections, updating things, adding users, whatever it takes. Monitor the performance of the system. Is it performing as the requirements specified? And of course, keep monitoring the security. One of the things that's often talked about here is a post-implementation audit. Many companies don't have the time or the money to do this, but the concept is this. You get an independent team, or you include some of the team members that did this, to go through and figure out, did this project, did this system deliver what it was supposed to deliver? Could it have happened faster? Could we have done it better? Could we have used less money? So the idea is you're improving. And you're also asking the people you originally interviewed up here, did this match your expectations? Did it miss? How did it miss? Why do you do that? 2 reasons mainly. One, to improve your process, and your people, teach them a better way. And 2, of course, to improve the system, because from that post-implementation audit, you may develop some stuff that needs to go into another systems development lifecycle. And this acceptance, I mentioned there's things you make lists of, and you start a new project on the very same system, to improve it, to move on, to make it better. And that's the systems development lifecycle. I can't quite read all this. I hope you can see some of it. It's not displaying real well up here. But what this says is guidelines for system development, and I've talked about these, so this is just a summary kind of. The top one says phases. Group actions into phases like we talked about. Different phases. This is the one people tend to minimize, tend to think not important. I can't tell you how many times people that are not involved with technology or don't have much experience kind of know, well, you know, to do that, all you need to do is yet. Well, how would you know? You've never done that job. Well, it looks easy. I've watched people do it. Well, why don't we ask the people that actually do it? That is an arrogance beyond belief. But programmers and people that think they're technically inclined often do that. Standards. Well, there's standards and procedures for the SDLC, and we talked about that. Systems Analyst stands in the middle. I know this diagram's probably a little difficult for you to see, but here it is. She's right here. Oh my God. Yikes. Everybody's talking to this person. She's right in the middle, and that's what's so much fun about the job as a systems analyst. It's great. You're right in the middle of everything. And that's a personality type. That's a certain kind of person that likes that kind of challenge. So as you can see, Probably a person that likes being a programmer wouldn't like being in that position. So there is a personality type, and there are personal and technical skills that have to happen. Most managers feel that if you can get a person that can handle the stress and the interpersonal parts of this job, you can teach them the technical aspects. Because that's more or less hard-coded. If you can teach people that easier than you can teach them how to manage people and projects. You may feel differently, but that's often what people think. Mentioned the steering committee earlier. They're right at the top here. They often use the analyst, tell them, go do an analysis, a thumbnail sketch analysis, feasibility study it's called, so we can decide which projects to do and which ones not to do. Here's the programmer. And the next lecture will be about programming, how that happens. But of course, very key person makes it happen. They implement based on what the analyst gives them. The analyst gives them stuff based on what all these other people tell them. And the programmer has some input to the process as well. They need to tell you how long it'll take. They need to tell you what language they're using, what language they recommend, if the company's using more than one, those kinds of things. Vendors. This is very important. Vendors have always in IT been part of the process. It's a very close relationship in most cases between the vendors and the information technology department. Often, and that's less today than it used to be, but often you have a very close relationship because you're using their hardware and software. And they need to keep you appraised of new changes and procedures and options, new products coming down the pipe, those kinds of things. But also, we'll talk about this later, but when you have requirements, you're going to give those to the vendor and say, here's what I need, what can you give me? And they'll give you a required, they'll match your requirements as closely as they can for this amount of money. That kind of thing. And they often include training. You know, if you buy their software. Webmaster, well, that's the person that's going to maintain any web applications you need. Wow, most companies, you know, unless you're a big company, don't have all these people, but security specialist. And that's, of course, one of the advantages of working at a small company as an analyst. You do a lot of these jobs yourself. Or the programmer isn't just a programmer, they're a programmer analyst, or they're a programmer slash security expert slash webmaster. You get the idea, the functions there, it just may not be in different people. Crucial today, security. Other systems analyst. Most places I've worked as an analyst, as you're developing these milestones I talked about, you generally present those to the rest of the systems analysts, if there are more than one, at weekly meetings, monthly meetings, whatever it is, so that they can critique. They may not know your project, they may not know the specifics, but they can listen to you and find things that you perhaps hadn't thought of. Or sometimes when you verbalize something, all of a sudden it doesn't make sense to you. Like, well, that's not too smart. I do that often. So the idea is if you have to express it out loud in front of people that have some experience with what you're doing, it's a good sounding board and it can tighten up what you're doing. Management. Well, as an analyst, I've often been in a position where I'm asked to do a project, but upper management doesn't support it very much. Possible situation, or nearly impossible. If you don't have support from management, and you're talking to all these people, you have the responsibility to make this work, well, if some of these people don't want it to happen, it won't. And what's your recourse? Nothing. If you can't go to upper management and say, I'm finding I can't get enough time with the people in payroll, or whatever the case is, and they will make it clear, people will cooperate. It sounds silly, but it happens. Projects start and the analyst doesn't get the right buy-in from the right people, and that's one of your first jobs. Who's paying the bills and who's ultimately responsible? Because it ain't me. Somebody on the business side. Find that person and talk to them, or the closest person to them you can find, and make it clear what kind of support you need for them, and make it clear to you how much support you're going to get. That'll help you make some decisions along the way. DBA, we've talked about databases, database administrator, data warehouse people. These are technical people, and they have to give you advice. You know something about databases as a systems analyst, data analysis, but these are the experts. These are the people you're going to say, look, we have this system, help me design the database, or what do I need? What do you recommend in terms of software or hardware? Those kinds of things. These people are crucial. Users are business partners, as I call them. Crucial to the process. You don't know the job, they're going to tell you. We've talked about that. Another technical person, the network person. Again, expert. So you don't have to know all the details. You just have to hand them the requirements and ask for advice, essentially. And then you incorporate their advice, document where you got the advice, into your proposal as you move along through the system. So that's a lot of people, a lot of tasks, a lot of functions. That's what makes a systems analyst job fun. Systems analyst responsible for designing and development of the system, obviously. And you need that primary contact person. Talked enough about that. Project team. The main thing is it has to be cross-functional. The old idea of designing within one department is long gone. The silo approach, they used to call it, where you design your stuff and heave it out of the silo into the next silo and let them deal with it. Not a way to run businesses. Nobody does that anymore. So the idea is you get a cross-disciplinary team, somebody from marketing, production, HR, payroll, I mean, assuming they're all involved in this project. Even if they're not, sometimes you get them involved, so that they can be a liaison to their department. They can be an advocate for their department. They can give you input from their department. So everybody's on board. So as you get closer and you develop a plan, the marketing department can now dovetail a marketing plan into your software, knowing when it's going to be delivered, and you get the idea. So there's no surprises. You know, often you design the best product in the world, but the engineers, when you get to production, say, we can't do that, sorry. So that's the idea. You get everybody involved as early as possible. Users, business partners, and technical people. One person has to be in charge, project leader. Okay, project management. You set your goal, objectives, and so forth, and this is called scope. Very crucial word. And let me just hop over here to the whiteboard. See, there it is. We're designing a production system. So, as you know, there's input, production, and output. The question is, if I'm going to design software to do that, where do I draw the boundaries? In other words, we have suppliers, vendors, we have distributors, we have warehouses, we have stores, we have customers, etc., etc. Now, do you want me to design a system that just does this, manages your production, or do you want to have a way for the suppliers to know what you're producing so they have a better idea, and your vendors, on what they need to give you, and they can plan based on your plans? Or do you want these people to know what you're producing and when things will be delivered automatically without calling somebody? You know, do you want them to have access to the software? If the decision is, no, I just want this part, that's your scope. And if that's your scope, then you can make plans. You can figure out what steps you need to make, how many people you need, what your budget needs to be, how long. All of that planning can happen. Then you can create those milestone documents and say, here's what it's going to cost, here's what people we need, here's the stuff we need, here's the schedule. Is this what you want to do? Do you want me to move on to the next step? And they all sign off and say, yeah, sure. So you tell them it's going to be done in 8 months, budget of $10 million and these people. So you've been working for 6 months, you're getting to the point where you're going to implement it and test it, and somebody says, hey, we need to add these guys into the system. That shouldn't be too hard. Well, in fact, it may not be too hard, but it's very hard to do now within your schedule and budget. That's why you have scope. This is called scope creep. And when you have scope creep and nobody documents it, nobody is held accountable for it, who do you think gets held accountable? The systems analyst. You didn't get done on time. You went over budget. And you can say, well, that's because you added this. And unless you make a point of it, in other words, you pull out that milestone document and say, this is the scope we agreed on. I can give you this, but I did some analysis. It's going to take us another 3 months and another $100,000. Now we can change our scope, change our resources, change our budget, and we'll move ahead. But it also means I have to go backwards, do design. You got to figure out how this is, what you want it to do and how you want it to happen, just like we talked about before. So you might be programming on this scope, but you got to go back and do analysis and design before you can program on the added scope. You get the idea. Crucial term to systems analysts, scope creep. Required activities, what you do is you actually make a list of every task that has to happen, down to very small detail, assign resources to it, assign time to it. How long is it going to take to interview all the people that are going to use the system? Time estimates. What? How long? Then you take cost estimates. That depends on how you're going to do it, of course. The order of activities. What do we need to do now and then next and so forth. And one of the crucial things is how many of these tasks can be done simultaneously. This is part of project management and project planning. And of course, there's what's called a critical path. Or some people call it, there's a CPM method, critical path method of project management. The idea there is what activities, steps have to happen to keep us on track. There are other things on the side that can be done peripherally or in parallel that are not critical, because if they take longer, it's not a big deal because this one takes longest of all. And that's called the critical path. So those are the things you do. Here's an example of what's called a Gantt chart. And if you go to these links, as I've mentioned before, you'll see some things on the web, a textbook web page that'll give you some better background on these things. And here's the main 4 tasks. And of course, if you drill down on the planning, oops, touch the board. If you drilled down on the planning, there would be tons of details. And notice this takes 2 weeks, starts here and ends here. You get the idea. But if you drill down, there's going to be a whole bunch of little steps in planning, and it's going to, sometimes you assign names to them, if not names, at least jobs or functions. And that allows you to manage, not only manage the project, at your weekly meetings, you can ask, how far are you along on this specific step? You've been assigned this step, how are you doing? Are you on schedule? Are you behind? If you're behind, how do we help you? If you're ahead, that's great. That means you can move on to this. So you have to have the plan. Talked earlier about feasibility. This is essentially great idea. Do we want to do it? I'll give you a great example of this. We were doing just recently, a couple weeks ago, we were trying to do a project with grant money with a university, I won't name it, and we wanted to do distance education with them. So they were looking at video systems to do this, and One of the higher ups at the university read an article on a plane. Ugh. When you work at IT, that's one of the worst things you can hear is one of the vice presidents walks down to the IT department and says, "Hey, I read this article on the plane. Can we do this?" Well, the answer, as I said earlier, is always yes. However, it'll take X amount of money and X amount of time. But this person at this university, which we shall remain nameless, read about holographic 3D video conferencing on the plane. So that's how they were going to spend their grant money. When I heard about it, I just laughed and said, "Why? What do you need to do that for?" But I also thought this might be fun. I've never worked with that technology, read a lot about it. Let's do it. So we started moving along. They got the budget for the project, and then they set the scope, the budget, the schedule, and so forth. And then they forgot to ask the network administrator. And after they'd moved quite a ways down and gotten the money for that project, the network person said, "Well, you know what? This hardware, this video conferencing hardware, doesn't work with our networking. It needs more bandwidth. It needs a bigger pipeline." "Oh, what does that mean?" says the higher up executive. "Well, that means we have to rewire all the buildings we want to do this in with new fiber optics." And of course, that blew the budget right out the window. Needless to say, we're no longer going to be having 3D video conferencing. But you could have avoided all that if you'd included the right people and done a feasibility. In that case, it would have been technical feasibility. Somebody would have looked at it and said, "This is cool, this is fabulous, but technically, in order to do that, we need to do this." But it's not really feasible unless you want to spend money to re-cable every building on campus. So it's not feasible. That's the key word, feasible. Not possible. As I said, almost anything's possible. Feasible means, is it reasonable? Does it make sense? So operational feasibility, an example of that might be somebody writes a program that allows you to get higher quality of reporting. And it's fabulous. The interface is great. You know, the design is really good and slick, and it's just what people need. However, to make it work, you have to have 8,000 people in the background gathering all these files, putting them in a certain location, processing them, moving them over to here, processing them more, shrinking them down, zipping them, putting them on this device. Now we can use that new software. Well, we don't have 8,000 people to do that. So we could get some of it done, but none of it would be done on time. Not operationally feasible unless you want to hire 8,000 people to work 24 hours a day. You get the idea. Great idea, it won't work. Schedule. Well, federal government says we have to have this done by January, and we can do it this way, or we can do it this really cool way, but the cool way we can't get it done. Or, more important to most organizations in business, we can get it done, but we can't get it to market till summer. By then it's too late. Somebody else will have something on the market. So that's what you're talking about with schedule. There might be deadlines. This is the one I've mostly dealt with. These tend to be easy to explain in most cases. This one is a little more hard. You look at the costs, which include people, hardware, payroll, trips for training, vendors coming in, luncheons. All those things are part of the cost. Training, programming time, documentation time, and so forth and so on. So that's costs. Benefits are divided into tangible and intangible. Tangible, of course, are hard numbers. Intangible are the soft things. The hard number is if we do this, we can reduce production time by 3%. 3% can be equated to money, essentially. In a lot of ways, less inventory, less people, and you can get things in the market quicker. We'll increase sales 10% as our estimate if we make this new improvement to our product. Those kinds of things. Cut costs, increase sales. Intangible is if we don't do this, our competitor are going to take over the marketplace and we're going to lose a lot of money. We don't know how much. In fact, the economic analysis may tell us we're going to lose money on this project in terms of tangible benefits. But the intangible is if we lose market share, they're going to have more money and they're going to beat their brains in with it by developing better products. So we need to compete so they don't get as much money out of their new innovation. And we get some of that. And then they're not making as much, we're making some, and so forth and so on. Intangible, for instance, when I worked at the supermarket Furs, we decided we wanted an online shopping store. And we were the first in the Southwest to have one. And I was in charge of that project. All the economic cost benefit or return on investment, ROI, that I did pretty much showed we were going to lose money on the project. The best estimates of increased sales weren't very big. Those days, shopping online seemed kind of weird to people. They did it. Amazon was around. Amazon was losing money, as they did for, what, 12 or 13 years. But groceries online was a little odd. But the goal of the company was to sell the company to investors in New York. And that was the goal. So the benefit, intangible benefit of creating an online grocery store was that we would have high tech, we would be in that marketplace, we'd be competing in an area the other supermarkets couldn't compete, we'd look like a better investment. We would be competent technically. People would hear about us and so forth. You get the idea. So we did it anyways, even though the economic analysis cost benefit, tangible benefits showed we'd lose money. All right. Well, documentation, that's the blueprints, if you will, so that somebody else walking in the door and their boss says, we need you to go fix the report in the payroll system. Well, if there's no documentation, that's very difficult to do. Documentation at least gives the person a start. Talked earlier about gathering information. As a systems analyst, this is a big part of your job. In the early phases when you're looking at the what, you're documenting the current, you gather information, and these are some of the things you do. Review documentation, that's not one of the first things you do when you walk in. Give me all your training manuals, give me all your forms. Do you fill out forms? Is there paperwork? Are there files? And what we're finding today, of course, is most of the stuff is digital. It's no longer a piece of paper in most cases. But if there is paper, you get it. If it's online, you get access to it, or you print it out, or you put together documents. What that allows you to do is train yourself, learn yourself. If there's training, you take that training, which is a form of documentation. Now you're getting a picture of what goes on. If you have the input documents and the output documents, that black box in the middle can make a little more sense to you. How did I get from here to there? Well, that's the processes. So it's a great place to start. Observing people, this is a good one too. You just kind of hang out. You introduce yourself and watch how the business runs. You have time. And that gives you a feel for a couple of things. Obviously, how they do, what they're doing, what they're accomplishing, what they wanted to do, what it isn't doing. You can see those issues. But the other thing about observing a business as an analyst, you can kind of get a feel for the culture in the organization. How does it run? How happy are people? Are people good at their job? Are people, that kind of thing, which can give you insight on how to do these next couple. Surveys. Well, surveys, one of the advantages is, of course, you can do a lot of people. You personally are involved. You make the document online, whatever it is, send it out, people can fill it in. You can make it anonymous. You might get information you normally wouldn't get, and you can survey everyone, not just a few people. So it's a lot of information, and there's software that will help you analyze it. It's a great way, if you have time and budget and so forth. You may not be able to do some of these. The next is interviews. That's normally a small group of people. But I always make it a point not just to interview the bosses, because you never get what's going on You just interview the bosses, so you got to interview everyone within the organization, top to bottom, or at least individuals that represent each part of the organization. And that's, of course, a skill. How do you interview people? Very important. The two most important things I ever learned is, one, at least pretend to take notes, whether you're taking notes or not. And then a technique I often use is, especially people that are, you feel like they want to say something, but they can't. You close your notebook and pretend like the interview's over and just talk, and sometimes things come out you wouldn't think. JAD, Joint Application Development, that's where the business partners are right there all along, right in the room with you, and it's supposed to be a shortcut. You essentially don't have to do a lot of this stuff because they're right there with you. So you're using their energy, their knowledge, their experience in the process. And research, of course, once you have all this knowledge, you can go out and look at research. What are other companies doing? How did they benefit from this? Specifically, what new features do they have that you don't have? All those things you can find out by doing a little research. Okay, why do we do this? I know this is much more than most of you probably wanted to know about systems analysis and system development, but this is a graduate class in technology, and that's why we're here talking about this. If this was a class, business class, graduate class in logistics, I'd be talking about the production at the car plant. So that old analogy about I don't need to know what goes on in a car doesn't necessarily apply to a class on technology, because that's what we're doing. We're looking at the inner workings of some of this stuff. So these are kind of obvious when you see them. Correct a problem. That's why we start a project. To improve, and normally you combine these. Rarely do you just do one or the other, because there's always problems. I don't care how long the system's been in place or how good it is, there's always problems. Just look at Windows. Enough said. Outside group may mandate change, like the federal government. They're always changing tax laws, so the tax systems, most corporations have to be changed year to year to year, which is, of course, why we have these businesses now selling home tax software, TurboTax, for instance, because they make the changes in the programs based on the new tax laws every year. You don't have to do it. But as a big corporation, when the government says, you know, next year you have to report this stuff which you've never had to report before. You have to report your carbon emissions in more detail, for instance. Well, you're going to have to change your computer system to do that. And this is a big one too. In order to compete, we need to do this. These seem obvious when you see them, but those are the major reasons we do this kind of thing. This is kind of obvious, a request. Bigger companies have these, and what they're for is the steering committee gets these, and once a week the steering committee goes through them. Reject, good one, put over here, maybe. Then once they go through the new ones, they integrate those with the existing ones that aren't done yet and prioritize again. So it's an ongoing weekly process or monthly, whatever it is. But the form allows you to get some documentation, some idea without a lot of work being done. So it's a way to request change in a system. Here's the steering committee. We've talked enough about this probably. Review, prioritize, allocate, form the team. And of course the steering committee is made up of people from different departments. It's not made up of technical people only. It's usually a upper management person or their representative that runs the steering committee. And you have to be careful about that, because what gets done, what gets approved by the steering committee, is going to help, might make or break certain departments or people. It's very important. So you try to get everyone involved so everyone understands what's at stake for other people. It's an old Japanese custom that they used to switch jobs, so the next meeting they were in for months at a time. And then when they went back to their old job, they'd understand more about why this person is asking for things. Similar here, there's an advocate for each department that, well, if you do that, you're not going to do my project for the marketing department. We're going to lose X amount of dollars. So you get, it's diversity again in a sense. And we talked about this, preliminary investigation. And when I did this for FERS as an analyst, I couldn't create a document that was longer than 1 or 2 pages at this point over here. No more than 1 or 2 pages, and it would have actually a return on investment. So I had to actually come up with figures on what it would cost and what we would save or how we would improve sales. Did I make up those numbers? No. Some of it I did research, because these numbers aren't expected to be accurate. You're not held to these later on. This is just to do a feasibility test. If you do it for every project, you can compare return on investment between projects. You don't expect to get that return. It's just the idea of prioritizing them. And I would find research, how, in general, in this industry, how many boxes of paper do we go through, or paper bags? If we switch to this system, we're going to use X fewer bags. So our cost savings is X. What's it going to cost? We need to get this hardware to do that and train these people. And these programmers do this. Cost, benefit, easy analysis. What's the interest rate? Return on investment. Couple of pages. Give it back to the steering committee and they make decisions based on that. Or they say, we need more information, go do more. This is when you're actually doing the project over on this side. Feasibility report. So the detailed analysis, and we've talked about this real quick as a summary. Current system, wants, requirements, recommended solutions. Sometimes you offer more than one. You may say, this is the one I recommend most for these reasons. Here's the disadvantages of each of these. Because sometimes you know that the VP or the CEO wants to do a certain way, but your analysis shows this other way is better. So you will include what they want to do, but kind of tell them this one's better for these reasons. This one, you don't say it's there, but you just kind of know it has to be included. And this one will have this disadvantage and these advantages. Someone else then makes the decision, the steering committee often, or the people on the project team. Sometimes called logical design, or what do we want to do? And then you propose a system, most feasible. I'm not sure what most feasible means, but perhaps the highest return on investment. And then someone else decides. You go, here's what I find out, put it on their desk. If you have any questions, ask me. But you don't decide what goes, someone else does. That's how the process works best. Often what you find, especially in smaller organizations and people that don't have a lot of experience with this, they make a decision here that we're going to do this. Well, this is an important difference between that process and an SDLC, Systems Development Lifecycle. You're making decisions all the way along after each step. Because you don't have enough information here is the theory behind this to decide you want to do this at this cost with these benefits. You need to do more work, and as you do more work, you learn more. So you're constantly making decisions, and you can kill a project at any time. But most people don't do that because they don't have the staff or the time or the experience or the knowledge on how to do that. They just say, we want to automate this. Let's go. Let's do it. Go on Google, type in meeting room software. See one for $5 grand. Let's buy this one. It kind of looks cool. I looked at the web page, talked to the guy. He sounded good. Let's buy that. Well, that works. You get a system, but does it do what you need it to do? Who knows? Until you implement it. Now people are using it and they say, well, this doesn't do what we need it to do. We'll make it work. That's normally what happens. The SDLC tries to prevent that. Someone else is making the decisions. Here's some approaches, general ideas, to how systems are developed. Buy a package. TurboTax. I buy one of those every year. Makes life easier. I could write a program. I think I know how to do that. But I would have to investigate all the new tax laws every year. I don't want to do that. I don't have time to write programs, so I buy pre-written. And of course, there's horizontal, which means it'll work for many different companies. Like a payroll system tends to be a payroll system, especially for small business, where there's no union contracts and so forth. A vertical market, so it's a particular industry like beauty salons. They have their own kind of software to manage their supplies and their beauticians and different skills that people have and so forth, scheduling, that kind of thing. That's the difference there. Advantages here are it's fast, it's tested, normally there's training, documentation. You purchase it, they come in, install it, or tell you how to do it, and you're up and running. Do a little training, and you're ready to go. It's not that easy, but that is an advantage of packaged software. You don't have to do all that legwork. You don't have to write the programs. You don't have to do this and that. Everything happens for you. The disadvantages, one, you have to take it as it is. And you see this often. A small business changes the way they do business to match their software. Big mistake. Happens all the time, though. You got to take it as it is. So you end up saying, well, it's 80% there. The rest of it we do manually on Sundays. Even though we're closed on Sundays, we have to come in to do all this manual stuff so we can enter it in the system on Monday and get things working again. That kind of thing. Two, of course, the expertise you might have gained developing the system yourself. And of course, you've given away some, as one implies there, as it is, you've given away some of the flexibility of your business. Okay. Custom software means you develop it yourself, write the whole system, go through that whole SDLC. And of course, the advantages are it's what you want. Right? It's exactly what you need, or as close as you can make it. You've got all your people involved. Your programmers gain the experience. They know how to fix it. They can modify it. They can enhance it. They can improve it. A lot of reasons to do that. Disadvantages, however, dollars, time. So resources. It takes a lot longer and a lot more money generally. And you have to maintain it. You have to make changes. You design the system. The federal government changes it. Who do you go to? You have your programmer write it. You only have one programmer and he gets a better job. What do? Well, you hope you can find a programmer that can pick it up before the company stops running. So there's a lot of those issues. You are more at risk in some senses. And outsource is the same thing as custom generally. There's two ways to think about outsourcing. One is you hire somebody to write custom software. That's outsourcing. We did that often at Kinko's because it meant we had to hire more internal programmers, because if you hire programmers, you got to pay their benefits. And at the end of the project, you can't say, thank you very much for helping us, go get another job. With outsourced programmers, and they came to the office and they sat at desks. They were there available for me. They were as if they worked for us. But at the end of the project, we could decide to put them on another project or send them back to wherever they were from, and they were from all over the world. Some of them would come from India, North Carolina, to California. The other thing, outsourcing, you may actually have someone else run the software, and it's software as a service is a new trend where you don't do anything with your software. You buy a service that does all these things for you, and they take care of everything. That's the new trend in software, virtual systems, and software as a service, SOS. So someone else does all the headaches, you just get the use out of it. In fact, the software we use to run these classes, you can buy a service from Adobe where they host, or in other words, you run all the classes off their server or wherever their company is. We don't do it that way. We bought the software and we host it locally here at New Mexico Tech. But you can get a service, you pay a monthly fee, and Adobe hosts everything for you. You don't do anything except use it. They take care of all the headaches, but it's such good software, there's not very many headaches. But a lot of people don't want to do that, so they let Adobe do it. Design, we talked about that. This is where you do the how. You're drawing up the blueprint. The handoff to the carpenters, the programmers, the network specialists, all those people. When you're buying new software or hardware, in this particular slide, gives you some thoughts on that area. Requirements, remember we mentioned those. Requirements. Well, you return those requirements into specifications. Very specific. The state, I haven't done this in years, but I used to make proposals based on the state of New Mexico's requests. And they actually have a document and they say, hey, we need these specific things. And you would answer it a certain way, check a box. And they gave you a score based on how you checked the boxes. And you didn't know the weight. Each question had a different weight. Each vendor would answer the questions, then they would run a program against that, your responses, and they would select vendors based on that. The idea is it made it objective. And they used these specifications to create that document. And then from, as I said, from that document, you get proposals, and then you look at their proposals and decide and make a decision. Here's some ways you do that. A request for quote, you actually identify what you want very specifically. And say, I want this specific hardware, these specific software or development. You give it to a bunch of vendors. They each come back and say, okay, these specific products and hardware, services, training, whatever it is, we can give them to you for X amount of dollars. And then you decide which one you want. And it isn't just dollars, it's also schedule, but it's also reputation. You talk to people that have used the company before and you find out how well they live up to their principles and what they promise. In this case, request for proposal, what you're saying is, here's our requirements. I'm not going to give you specifics on the products. You just put together a package of what you think you should deliver to us. That's an RFP, request for proposal. This is just a quote up here. This is a proposal that may include staffing, training, travel, a lot of things. The request for information, this is when you know you need something, but you're not far enough along to really ask specifically for quotes or proposals. So what you say is, our system, we know it kind of needs to do these things. Can you give us information on how your systems do these things? Request for information. Works really well. It's a way to do research without you doing all the legwork. You just send it to specific vendors. The ones that don't respond are out of the running. Those that respond, at Kinko's, of course, a big company. If we did this, we got a lot of responses, and people were even willing to come out and make presentations at the corporate office in California. A lot of business. A VAR, this is somebody that sells someone else's software and hardware and then makes it better for you, packages it somehow, gives you maintenance, gives you updates, does everything you need. The great example of this is probably Linux. Linux is an operating system that's free, but you can buy it, support from companies if you want to run Linux. You don't pay anybody for the software, you pay somebody to keep the software running. Value-added network. Reseller, sorry. There's also value-added networks, but how do you decide which vendor? As I mentioned, you may ask them for a list of people that have used the software, and you might say to yourself, You know what? They're going to give you only people that like it. Well, I don't know. That's true. What you can do is call those people and say, do you know somebody else that uses it? And they say, yeah, there's a guy down here that uses it. And you can run a trail then and get a better picture. You got to start somewhere. And you talk to those current users. Demonstrations, they come to you or you go to them and they show you what they have. Trial versions, you can run the software for a while, get your users to run it and say, yeah, that works, doesn't work. Benchmark, measure the performance. We were looking for new operating system or compilers at one time. We'll talk about what compilers are next time. It's something that turns computer source that you type in, that the programmer types in, converts it to machine language. We were trying to improve that process at a company I worked for years ago. So we were running benchmarks, which vendor had the best compiler. And to make a long story short, a short story shorter, we wrote a COBOL program, or a program that all it did was run the same code 10,000 times. So there's only 2 or 3 lines in the program. And there was no output, and there was no input. It just started and did this loop, it's called, 10,000 times, and then it ended. So some of the compilers would compile it, and then we'd see if it runs, how fast the program runs 10,000 times. And, you know, that some of them were better than we had, some of them were worse. The Hewlett-Packard compiler ran instantly, just ended. So we called HP and said, I think there's something wrong with your software. It turns out their compiler was trying to make things fast. So it looked at the program and said, there's no input, there's no output, we don't need to do anything. So the program did nothing because it didn't have to. Running a loop 10,000 times if you don't have any output, what's the point? That's efficient. So that was a good benchmark. And we went with their compiler because that made a lot of sense. It actually analyzed the program and decided what it needed to do. All right, detailed design. This is where you're actually designing the how, database, the hardware, the programs, and the screens, the reports. For instance, picture's worth 1,000 words. You might show somebody this. You no longer use paper for these things, but you can mock up something on the screen. You can do this really well with Access, by the way, database software we use in this class. You can design forms. And the idea, of course, here is you can create a document, try to draw a picture in the document, show it to people. Who reads documents anymore? The idea is you show this to them. They look at it and say, you know what? You forgot telephone number. Oh, it's on there. You forgot date of birth. I don't know. You forgot some data that we key in every day. So this isn't a real thing. This is just something that looks like the real thing. And it allows the user, the end user, to look at it and say, that'll work or it won't work. Picture's worth 1,000 words. And this is how you lay out those forms. We're not going to go into that. You can do it in Access. Prototype is really used a lot these days, even not just in software, but even in business industry. I can assure you there was a lot of prototypes of the iPhone floating around before the iPhone hit the market, before it got produced. So at Apple, I'm sure there was prototypes of the iPhone all over the place. So a prototype allows you to put something in somebody's hand, and they can look at it, feel it, touch it, look at the color, instead of a picture on a piece of paper. So that's the idea behind a prototype. You can run it, kind of feel what it is, decide. And the idea, of course, one of the ways to think about a prototype is it allows you to fail early, in a sense. Because if somebody will look at it and go, no, that's too big. Or what is this thing sticking off the side? Get rid of that. I'm sure that went on with the iPhone. You know, Steve Jobs looked at it and said, no, that's too big. That's too thick. That's too this. It's too that. So, you know, that's a prototype. Fail early. Prove on it. People get involved with a thing. With a document, it's hard to get involved with. Something you can actually run, get involved with. I'll tell you a little story about prototypes. I was developing medical billing software, and sometimes you get bored and you keep getting the same error. So I put an error message in there when I got to a certain one that I was trying to fix. said, "You idiot, how many times are you going to do this?" Well, just about then, the CEO came by to see how we were doing. Of course, when he ran the prototype, that error came up. Kind of embarrassing. But fortunately, he had a sense of humor, and I explained that I was the idiot, not him. He thought it was funny, but do things like that. CASE, computer-aided software engineering. This picture is a CASE software, and it's a software that allows you to enter tasks here, details. You can double-click on this. It'll show you the details there. This is kind of these are entities. Marketing department, vendor. This is the process. And if you drill down in that process, it's going to have sub-processes. So you can document all these details you're putting into the design and do it online so other people can look at it. This is the way we do things. We used to have to draw with templates and things on paper. Horrible way to do things because you tended not to want to change it. So now we come to the phase where we actually do it. We create the programs. Programmers do that for us, but we're involved because they're asking us questions. They look at our design, our details. This program needs to do this, 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 this. They make it happen in the machine. We install the system and test it. This is a key one often forgotten. Train the users. And then we convert the system. We create a new system and we get rid of the old system. Let's look at some of the details on this. Unit testing. When we're testing, there's 4 types of testing. That means individual program. Normally the programmer does that. In the design, you give them, here's what should come in and here's what should come out. Kind of a black box approach. The program's a black box. Then you give them details. Sometimes you don't give them details on how to do that. You just say, here's input, here's output. You make it happen. So they test their own program. And if it does what it's supposed to do, they move on to the next test, which is combine all the programs. And one programmer may not write it, all the programs. Usually they don't. In fact, I know at Ford and GM, programmers don't even write all of the one program. They write parts of it because then nobody knows what the whole program does. They test their part, then they integrate all those parts into one program, then they test that program. Somebody else tests that program. Nobody then knows what's going on any one program. Then you test the programs together. The output from this program goes to this program, which then goes to these programs, so you test them as a group. That's in essence a testing the application, not the program. Then you integrate the application with the other applications, and this in essence is systems testing. Integration testing, systems testing. You're testing the system as a whole. Then we get down to the last step, which is where the user, business partner, runs the system and decides, yeah, that works. The key to this, one of the keys, is the data. As an analyst, you should be working with them early on, deciding what data you want to test. You get live data out of the database, put it over in the test system, and you run it using real data, if you can. So those are the tests. Once you have acceptance testing, you have a system. Training, what is training? We all know what training is. When you convert the system, there's some decisions to be made here, and there's advantages and disadvantages to each of these approaches. Direct conversion means on a certain date, notice time, on a certain date, the old system goes away, a new system comes up. This is how people that don't understand technology do things. They say, I tested it, who cares? It's going to work. So tomorrow, we throw away the old system and we use the new system. This is cheap, easy, very risky. quick, all those adjectives, but it's very risky. Because once you turn off the old system, you can't go backwards. Oh, no, the new system didn't work. Too late. You just entered all your data in the new system. Going back is essentially a conversion at this point. We need to convert back to the old system. Very risky. Parallel, the new system starts here, but you're still running the old system in parallel. And of course, the advantage of this is you can compare reports from the old system and the new system. If they're the same, that's good. If they're different, it better be because you made an improvement or fixed something, and you know why they're different. And you don't turn off the old system till you're satisfied you accept the new system. Essentially, you're testing the new system. The disadvantage of parallel, of course, is it's more expensive. You're running two systems. So you've got to have people enter data into two systems. You've got to have a test system and a production system that are the same size. It's double the work. But there's almost no risk, because if you find this isn't working, you turn it off. You still have the old system. Then you go back to the drawing board and fix the new system and do another parallel. Almost no risk. Phased is, of course, a parallel conversion, but you're only doing bits and pieces of the system. So you turn on this part of the system. If that's okay, then you turn on this part of the system and keep this one going, and you get the idea. You just turn on parts of the system. Why do you do that? Well, it's not everything at once. You can focus. Is this part of it working? All right, good. Let's move on. It's that kind of thing, breaking into smaller bits and pieces. And again, as in parallel, very expensive, but in complex systems, it's the only way to do it. It's too complex to do everything at once. And there might be technical reasons for that. You don't have enough systems to do the whole thing right off the bat, so you phase it in. And you might turn off the old system. As you can see, that's what happens here. As this phase worked, you no longer run the old system with this phase. So now you don't have to have double the system, just parts of it are double. And a pilot means it means you take one company. If you have a large company with 1,000 branches, you're going to do one branch, see how that goes. You don't usually do one, but you do fewer. You don't do all the branches at once. You do a few as a pilot, see if it works. If it does, then you can start doing another one. At Kinko's, we would do parallel for a while, and a pilot sometimes, and then we would do a phased conversion sometimes. But the pilot we had to do, 3,000 locations, you would do a pilot. There was one store up in Santa Barbara that loved doing the new stuff. They understood what the problems might be. We also had a matrix of stores around the world that had these specific situations and these specific pieces of hardware and these specific environments, so we'd know, well, if we test this one, we'll have tested that environment. So we actually had decided on which places to do pilots, test different scenarios. And those people generally loved the challenge of the new software. Didn't complain as much either. So we would do pilots, and then eventually we would do phase, but not by necessarily the software, but by markets, districts, that kind of thing. And sometimes the districts fought over who got it first because it would make a difference. And the final thing, of course, is you make sure the system works. And you keep it working. You perform maintenance. And don't forget the post-implementation audit. That means you look at the system, as I mentioned earlier, ask people, did it meet your expectations, and so forth. Security plan. Notice here, you're looking at assets. That's really what security is about. What do we stand to lose? And it's often information, of course, but that's tied to reputation. if somebody steals credit cards, that you take a big hit in the news, those kinds of things. So that's what security is about. It's who has access, how do we limit access, how do we make sure access is good, and that has to be part of the process from this day one. I'm not sure what this has to do with systems, but if you get a chance, look at this. It's very interesting because Lucas films, it's a little dated, but they were talking about the first Transformer film in here. And the amount of data they store, it's all video stuff, and what they do with it is it's remarkable. And they show all the stories. And so if you get a chance, take a look at this video. Very interesting. And I believe we're done. So more than most of you ever want to know about systems management, system implementation, system development. But it's what we do here in this class. We look at the background, we put the pieces together. The next time you're at a meeting talking about new systems, maybe you'll have some understanding of how it should be done. Or if you work at a big company or big school system, you might be asked to be part of a team that does this. Or takes a look at the feasibility of long-term software for the organization, and you'll have a better idea, better understanding what the heck you're doing. Also, if you're asked to take part, you'll understand what you're doing in terms of advocating for yourself. This is what I need to have happen. I know what you need to do to make that happen, so you can work together. So I guess that's it. See you next time. We'll talk about programming.